Hi everyone and welcome to Smart Culture Education. This is the place where we make learning simple, clear and engaging. If you're new here, don't forget to subscribe so you can join us on this journey of mastering maths, science and more.
A ball is projected horizontally at 27 meters per second from a vertical cliff. It travels a horizontal distance of 40 meters before hitting the ground. Assume that air resistance is negligible. So in the first part here, I'm going to number this question 1. We have to calculate the vertical velocity of the ball just before it hits the ground. Okay, so let's think about this scenario for a second. The ball is launched horizontally. So that means it starts with horizontal velocity only. That also means that it has zero vertical velocity initially because it is not thrown up or down. Gravity acts vertically to increase the downward velocity over time. So step 1 for us would be to identify the known quantities. And what I'm going to do is I'm going to actually list them. So the horizontal displacements, I want you to think about your horizontal and vertical directions here. So remember, this is the x-axis and this is the y-axis. So let's quickly think about all the known quantities. We have the horizontal displacement. Displacement is represented by the letter S, and because it's horizontally, I'm going to put a little x there. The horizontal displacement is equal to 40 meters. Okay, how do we know that? It's given. It travels a horizontal distance of 40 meters before hitting the ground. So this is given. Okay, and then they also give us the initial velocity, the horizontal initial velocity. So I'm going to list this as well. This is 27 meters per second. Then what else do we have? We have the horizontal acceleration. It is equal to 0. Why is the horizontal acceleration 0? They tell us that the air resistance is negligible. So there's no other forces acting horizontally. So we can assume that this ball is traveling at a constant speed, which means the acceleration will then be equal to 0. Now, what is the vertical initial velocity? Let's quickly write that down. So that's going to be represented by the letter U and the letter Y here because we are thinking vertically. This is going to be 0. And let's quickly think about the vertical acceleration. Now, the vertical acceleration is not going to be 0 like the horizontal acceleration. The vertical acceleration is going to be equal to the gravitational acceleration, and we know that that will be 9.81. To find the vertical velocity, and that is what they want us to calculate, they are asking us to calculate the vertical velocity. To find the vertical velocity, we first need the time of flight. So what we'll do now is we'll calculate the time using horizontal motion only. Now we know that the horizontal motion is happening at a constant speed, so what we can do is we can use this formula over here. We can say that the displacement is equal to the initial velocity multiplied by the time. So we know that the horizontal displacement is equal to 40, and we know that the horizontal initial velocity is equal to 27. Now we only have one unknown t, so we can solve it. So what I'm going to do is I'm going to divide by 27 so that I can get t alone. The 27 above the line and below the line will cancel out. Whatever I do on the one side, I have to do on the other side as well. And if I divide 40 by 27, it gives me a value of 1.481 seconds. So the value of t, I'm just going to write it down, is equal to 1.481 seconds. Now that we have the time, we can calculate the vertical velocity. So the ball is in the air for about 1.48 seconds. Now we are going to use vertical motion to calculate the final vertical velocity. Now, vertical velocity is given by the following equation. V equals U, which represents the initial velocity, plus A, which represents the acceleration, multiplied by T. T represents the time. So we know that the initial velocity, the vertical initial velocity, is equal to 0, and we know that the acceleration is equal to 9.81. And we know that the time is 1.481. We just calculated the time. So we can substitute all these values into the formula. It becomes 0 plus 9.81 multiplied by 1.481. If you punch this into your calculator, what do you get? Okay, so it's 52861, so that means if we round to 2 decimal places, it's going to be 14.53. Okay, so the vertical velocity just before the ball hits the ground is equal to 14.53 meters per second. I'm going to write the answer here. Now, in part 2, we have to calculate the height of the cliff. So now that we know the flight time, we can calculate the vertical displacement, which is the height of the cliff. So what we are going to do is we are going to use this formula. The displacement is equal to the initial velocity multiplied by the time plus a half multiplied by the acceleration multiplied by the time squared. So now we can just substitute the known values into this equation. Now we know that the initial velocity is equal to 0. Anything times 0 is 0, so we don't have to substitute the value for t in this first part. Okay, and then what is the acceleration? The acceleration is going to be 9.81. What is the time? The time is going to be 1.481, and we have to square that. Now, if you punch this into your calculator, you will get a value of 10.758 meters.
Thank you for watching today's video on Smart Culture Education. If you found it helpful, don't forget to hit the like button and subscribe to the channel. And if you want to stay updated, tap the notification bell so you never miss our next lesson. See you in the next video.